Hello, my name is Jenny Nicholas. I'm a PhD student in the Material Science program at UCSD. My research interests are in battery shorting behavior and solar resource estimation. I'm currently in Santa Fe, having just visited the Los Alamos National Lab. As geothermal district heating and cooling systems have evolved from their R&D phase, it is exciting to work on the deployment side for our project in Cascade, Idaho, which offers a generalizable blueprint for other rural American communities. My other team members are currently distributed around the world, and I hand the floor over to them.
Hi, my name is Hua, and I'm currently based in Shanghai and also experiencing the harsh winter conditions here. I'm a PhD student in the engineering school at UC San Diego, and my research primarily focuses on power system and electricity markets. And previously, I worked on battery storage.
Hi, my name is Maitri from Team DavidsonLab. For me, attending COP28 discussion and demonstration has underscored the importance of effective stakeholder engagement and robust planning, given the unique requirements for capital as well as other characteristics of geothermal energy, as is the case for the Cascade project in Idaho.
Hi everyone, I am Shaini Chaudhary, a third-year PhD student in UC San Diego in mechanical engineering. My research is focused on studying advanced nuclear reactors in a high renewable future. Right now, I'm joining from a village in Odisha, which is a state in India, and it faces at least 1 to 2 hours of blackout every single day. And families have to rely on diesel generators to make up for it. I'm very curious if engineered geothermal has any potential here. And in that regards, this competition has proven really timely.
The state of Idaho is often referred to as a gem state due to its rich natural resources and scenic beauty. It boasts a diverse landscape ranging from fertile farmland to rugged mountains. However, Idaho also faces a crucial energy challenge. The state largely relies on natural gas for its heating and cooling needs, a dependency that's neither sustainable nor cost-effective in the long run. In our quest for a sustainable solution, we turn our focus to Idaho's rich geothermal resources. The state's abundant geothermal hot spring and reservoirs provide an ideal setting for geothermal district heating and cooling systems, offering an eco-friendly and efficient alternative to traditional energy sources. Our site selection brought us to Cascade, a rural city in Valley County, with a population of over 1,000. The city is marked by a blue star on the figure to the right, showing its location in one of the areas with the highest geothermal potential. Many Cascade residents are using a heating system fueled by heating oil and propane. Recently, the city has received some Department of Energy funding for geothermal development. Cascade is characterized by its aging population, aging infrastructure, and decreasing migration rate. Smaller rural cities like Cascade often receive less attention from national funders and find it more challenging to navigate federal and state energy incentives due to a lack of resources. Therefore, developing a GDHC system here can potentially bridge this gap and set an example for other rural communities in the US. Now, let's delve into our project site. The city currently has 8 drilled wells, of which 3 are active for direct heating, with temperatures up to 103 Fahrenheit, making them sufficiently warm for our project purposes. Our system will consist of production and injection wells in the northern part, along with a heat distribution network that runs to the downtown area. This network will connect existing wells and serve the heating needs of major commercial and residential facilities, including key institutions like the Cascade Medical Center and the school district. We have had productive conversation with these stakeholders during our engagement process. From our assessment, we found this site optimal due to its techno-economic feasibility, conducive regulatory environment, positive social impacts, enhanced community engagement, as well as its diversity and inclusion effects.
Thank you, Tyson. Now I will talk about our stakeholder engagement process. At the onset of this process, we referred to available reports to determine potential stakeholders. As we became more ingrained in the project, our ability to identify key stakeholders and decision makers improved, and connecting with Mayor Nazula of Cascade proved especially valuable and insightful. Some key takeaways from our stakeholder engagement process was that we truly had a diverse involvement of various folks, from local government to education, healthcare, environmental groups, and technical experts. We tried to have high-level engagement with all folks and prioritized high-level contacts such as the mayor, city engineers, and heads of major local institutions. We are also very proud of the communication toolkit we created, which includes a website with project overview information accessible to the public, as well as a one-page FAQ with information about the project, which can easily be circulated. We will now discuss our permitting analysis. We began with the use of the Rapid Toolkit to identify relevant processes. We held discussions with numerous authorities having jurisdiction and permitting agencies to verify our findings. We address here two scenarios. The first is our baseline project, which utilizes existing wells with geothermal heat pumps requiring no new drilling. The second is our innovation scenario that involves drilling new wells with enhanced geothermal systems. As we would expect, the baseline scenario involves fewer permits, while the innovation scenario requires additional permits due to the need for ground disruption. Here we have a flowchart and milestone schedule of developing a GDHC system in Cascade. As you can see, from project kickoff to operation, we are looking at a 2.5-year timeline, if all goes smoothly. We also can see the differences in what types of permits would be needed for the baseline project in gray and the innovation scenario in green. Here we have our permitting matrix for the system, and you can find out more in our report. So in general, we wanted to discuss overcoming potential barriers in the permitting process, and we would recommend the following actions. First, it's important to ensure all permits are applied for under the correct name. Otherwise, this will delay the project. It's also important to maintain a good relationship with the landowner where the well will be drilled. Otherwise, this may cause issues in lease or purchase negotiations in later development stages. And lastly, we would really need to confirm that local residents are on board with this project and maintain this level of support. Otherwise, they may form local opposition groups. This is why community engagement is so important, and we plan to address this strategy during our event.
For the Cascade Geothermal project, the proposed system includes 3 existing production wells and also a network of distribution pipelines. The city will establish a project entity for providing heating and cooling services and meet an estimated 29K million BTU energy demand in total. Here we also show additional technical metrics and also cost breakdowns. For the business models, we consider 3 scenarios that vary across asset ownership and degree of control. The total system capex also varies. And under each scenario, we identify incentives from the federal, state, and also local levels. We use green and red dots to represent funding probability and also cash on hand requirements. Here, we also want to highlight the project timeline in the baseline scenario. The first 2 years will be the planning phase where most grants and also loans will have to be secured, especially the DOE and also Idaho Power ones that can meet the cash on hand requirements. The construction phase takes around 2 years, and then during the operational phase, many tax incentives, especially RA ones, can be used for both the project developer and also customers. We developed a financial model and also compare several key metrics under each scenario. For the baseline, for example, the LCOH is estimated to be around $19 per million BTU with 600K cost savings for local customers by replacing the blended fuel costs. The project also has 2 tons of carbon emission savings each year. And overall, we believe that the project will succeed given the favorable policy environment and also local backing seen in our engagement process. However, obtaining municipal bonds and also private equity will still be critical to ensure financial viability. We also highlight the incentive limitations here, including the lack of exploration target incentives and being non-stackable and also stringent cash on hand requirements for certain programs.
To sum it all up, we would be thrilled if we were to win this competition and have the opportunity to hold our stakeholder engagement event, which we would call Redefining Rural Energy: Cascade's Journey to Geothermal Solutions. We would plan to bring all stakeholders together and really educate Cascade residents, in addition to teaching a class of high school students about geothermal energy. We would hope that this could be a model for Valley County and beyond, as we would invite other Valley County commissioners and the Association of Idaho Cities to attend our event. We would be excited to have our event hosted by the mayor of the city. We hope that we would see you there.